Muhammad, Abdullah Muhammad, Abdul Rahman, Ahmad Mansoor, Ahmad Yusuf, Ali Hussain, Bani Abbas, Budur Ali, Fatma Ali, Fatma Ibrahim, Fatma Jasir, Fatma Muhammad, Fatma Yasir, Fatma Khalifa, Hashim Haidar, Issa Ghanem, Noor Ali, Huda Sayyid, Jinan Mohsin, Malak Sayyid, Maryam Ali, Maryam Sayyid, Mazen Nabil, Mohammad Haitham, Mohammad Zuhair, Rania Faisal, Rayan Jassim, Deep Ali, Rohan Eman, Sayyid Ali Jawad, Fada Ahmad, Zahra Ali. Okay, we are going through the engineering career, different things about engineering career, and we have went through the steps you need to follow in your career. Then we moved on to the tasks and responsibilities of an engineer, and then we moved on to the different types of engineers, and we also looked at how as a civil engineer we can need other types of engineers as well. Okay, so we should know about them so that we would know what we are dealing with. Okay, so we are not only dealing with civil engineers. I mentioned a number of times earlier. These are just other engineers which we may deal with, but there are many other types of people which we have to deal with in our career. Okay, how engineers solve a problem? Very important, right? No? No? Okay. We have already mentioned that engineers are problem solvers basically. When we started the discussion from the first slide, we said we solve problems for the society, right? Okay. So how do we solve the problem? We have to solve it using a method and with an analytical mindset. Okay. In the previous lectures, I have told you that what is our main asset, what is our main core as engineers. What is the thing which we must know? Two things. What were those? English and Arabic, right? Right or wrong? Right? Very good. The people in Pakistan are not engineers, right? Don't know. Nobody from Pakistan, Bangladesh, France, Germany, nobody of them have been engineers. Okay. Yes. What are the things which we should know always? Must. Other things you may know, you may not know. But these things you should know. What are those? Anyone? Take a guess. As engineers, what you should always know. What is your main abilities? Maths and science. While you are doing this one, see if you sit here and then hit you, go somewhere else. There. Boys don't come, they are all they're spending their nights in masjid, right? Pray all night. Okay. So yeah, science and maths. Okay, science and maths. Okay. So when you are solving the problem, you have to apply them. You have to apply them. Okay. So there is no, there's nothing about okay, I will solve the problem using some innovation or using some artistry or using my language skills and so on and so forth. Because in that case, everybody may give you a different answer. Okay, I bring a problem, I bring it to this guy and that guy and this engineer and that engineer, and everybody is telling me something different. Okay, obviously one of them will be correct, right? All of them cannot be correct. Okay, so as engineers, when we are proceeding for solving our problems, we should proceed in a manner which is on the basis of our own abilities. Our main abilities are the knowledge and skill of science and maths. Okay, so these abilities guide us which method to follow. Okay, and what steps and what type of calculations we should do when we are giving the solution to our problems. Okay, clear? It's not like you will think for 10 minutes and come with a solution. No, there is a method, you have to follow it. Okay, and analytical also means that you have to give some evidence. Okay, you have to give some evidence as well. For example, somebody says that I need a building for a classroom. Okay, so then you tell them, okay, you will need this much area. A very small, simple problem. Sit there. Give it to, give this to, yes. So you tell him, okay, you want for these many students and these many classrooms, you will need this much area for the plot. For the land, you need this much land. And he says, okay, why this much? Why not smaller? Why not bigger? Okay, so you tell him, okay, I calculated the number of seats and number of students, and each class will take this much area, and each class should have this much empty space, and so on and so forth. Okay, so then you need this much area. Okay, but then he may ask you, where is your proof? Why this much area? Why one seat will require 1.5 meters? Tell me why. Okay, or why there should be this much open space in my classroom? Why? Okay, so analytical means you will show him some calculations. If they're not, if the calculations are not available, you will show him some standards, some rules, some regulations. Okay, so this all comes under analytical. Okay, whatever you are doing, nothing is based on your opinion. You don't say, okay, I think the seat should take this much, or I think the instructor will need this much space to move. There is no think. Okay, like we think, yes. But we don't say that I thought this is this much and I know. You have to show him some calculations. I did some calculations. This is a standard width and so on. Clear? Okay. So you have to follow a method, and you have to, in your method, there should be some calculations and numbers involved. This is how you apply science and maths. Okay. These are the typical steps, but these are not the only steps. Depends upon the problem, obviously. The first thing is define the problem. What is your problem? Okay. The first step is define the problem. So in defining the problem, you can have, for example, a problem can be, there's a problem. Okay, I see cracks in the wall, for example. Okay, so that's a problem, right? I see the problem. Or sometimes the problem can be what I want to achieve. Okay, problem can be what the goal which you want to achieve in the future. Like I gave the example of the classroom building. So there is no problem right now. There is no problem because there are no students, right? There is no building, so there is no problem. Okay, but now he is telling you what is his goal. The client is telling you what is his goal. So his goal becomes your problem. Okay, the problem which you want to solve. So problem doesn't only mean something negative, something bad. Problem can also mean the goal which you want to achieve in future. Okay. Then gather more information which is related to the problem, which is related to the goal. Okay. So you gather relevant data, and you also look at the existing solutions. Okay. So what type of buildings are already built for the classrooms, for schools, for universities? What types of buildings are there? What type of structures are used? Okay. And if you take the problem of the cracks in the wall, so when the cracks happened previously, what others have done? Okay. So you gather more data and more data about the problem as well, about the goal as well. Okay. So he says a classroom building. You ask him, okay, how many students you are going to have? How many people you will have in each classroom? Okay, what type of classroom you will have? You will have auditoriums, big halls, or you want to have small classrooms? Will there be any computer labs or only classroom seats with seats? Okay, so you also gather more data. If it's a crack in the wall, okay, then more data can mean okay, where are the cracks? Are they in all the walls or only walls on one side? How big are the cracks? Okay, how far they are going? Are they going from top to bottom in the whole wall, or are they in a specific place? Okay, so you also gather more data about what you want to achieve. Okay, if it's a problem, you gather more data about the problem. If it's a goal you want to achieve, you gather more data about the goal. Okay, then in order to solve this problem or to achieve that goal, what other people have already done, what have already been done in the past. Okay, and from where you will get this data, what others have done already in the past. From where are we getting this data? How do I know that the walls? So you are a fresh engineer. Your client, calls you that I have cracks in my wall. Now, what do you do? From where do you know what to do with cracks in the wall? Drawings. Drawings. Sorry. Who will tell you that this problem happened previously? Who will tell you? Drawings will not show the crack, but yes. History of what? History of banning. Whose history? Who should you go to? Give me a simple answer. Okay, don't give me political answers. Drawings and history and so on. History and maths and science. Yes. Yeah, engineer who did the building. Okay, you ask him. Okay, who was the fool who constructed your building? And then he will tell you this was the fool, and you go to him, Mr. Fool, what did you do? Okay, no. Yeah, but you can ask the engineer. Okay, senior engineer. Senior engineers who are in your company, you can. Then you have to. This also brings us to a very important point that, which I already mentioned, the networking aspect. Okay, have to be. I mentioned earlier, right? As an engineer, networking is a very important part of your job. Okay, or a very important part of your career. This is where networking will help you. Okay, maybe this is the first time it has happened in your company. Okay, or the engineer who was before you, who already left the job. You already left. This is why they hired you. It happens, right? Okay, you only need one engineer in the company. There's one goal and one cause. So you don't have anybody else. Okay, so this brings us to the importance of one of the aspects of engineering career, which is networking. What others have done, you have to ask others. Okay. Going back to the classroom building, for example. Okay, there's a classroom building. There are many buildings which are constructed for schools and universities. But who will give you the details? Who will give you the details of those buildings? What type of structure? How much concrete? How much steel? Okay, who will give me those details? I need someone who is in my field and who has knowledge about this. Okay, so to look at existing solutions, you should have a very good networking platform. Okay, a very good network of professionals which are in the same field. And yes, you can do searching, Google search and on, but these are technical items which you may not find easily on Google or even on ChatGPT. Okay, but these details are not available. Okay, there are thousands of buildings constructed every year in the region, and people don't post them on Instagram. This is the drawing and this is. Okay, what material you find on Google and ChatGPT is basically slides, teaching material. Okay, but the real actual material, the practical material, is not usually uploaded. Okay, so you need to have a good network to see what has been done in this regard in the past. Okay, you may find some information by searching, but it will be superficial. It will not be detailed. Okay, it will not be relevant as well. You may find something about cracks in the wall in Canada. Okay, that this happened and this and then they did this and this and this. Yes, it was all very nice for there, where they can reach up to 0 degrees. Okay, but not here. So you need a good network. Okay, where were we? Yeah. A very important aspect is analyzing the requirements of different types of solutions. Okay, so for example, you want to construct a bridge. Okay, you can have a steel bridge, you can have a concrete bridge. If you go for a steel bridge, then the construction method will be different. You may need other types of contractors. The same contractor cannot do the work for you. Okay, so you have to analyze the requirements. If I go for this solution, I will need this. Okay, if I go for this solution, then I will need this. Okay, so cracks in the wall, I can demolish the wall and make it again. Okay, then I will need simple labor and masonry and formwork and so on. Or I can bring something, a chemical, and I can apply it and the problem will be solved. Okay, both solutions are there. For the first solution, I may need more labor and more time. For the second solution, I need less labor and less time, but it may still cost me more because of the chemical. Okay? There. So, look at different solutions, what others have done, but also look at their requirements. The best solution in terms of solving the problem may not be the cheapest one, or may not be the fastest one. Okay? So, you have to look at these things as well. So, the second step is research and gather information. Then you brainstorm and plan. Okay? Anybody knows brainstorming means what? The storms that you have in your brain, right? Yes. Thinking what? Deeply. Yes. Thinking deeply. Anybody else? Yes. Ideas. Coming up with ideas, right? Okay, and these are random ideas. Brainstorming, the reason they call it brainstorm is right now you are just trying to search all types of ideas. Just like a Google search. Gives you everything, right? Maybe 100 pages. Obviously your brain will not give you 100 pages of ideas, but you get the idea. You get the point. Brainstorming is you are trying to think about anything which is possible. This is brainstorming. Okay, anything which is possible. Okay, demolishing the wall, demolishing the entire building, just to solve the crack in the wall. This is an idea, right? And obviously, all of them will not be applied. But brainstorming means looking at all possibilities, no matter how insane it feels, how mad it feels. We just bring it out. Okay, what can we do? Clear? Okay, so this is brainstorming. And then you plan. Okay, so you brainstorm any potential solution, anything which can solve this problem, anything. Okay, and then you have to consider when you are planning. Then you start considering other factors. So I have 10 ideas ready. For each idea, I will see how much cost it will take, how much time it will take, and what will be the feasibility of the idea. Meaning, is this idea a practical one or not? Okay, is this idea a practical one or not? Somebody gave me an example about a software. They developed, no, not a software. It was a mall, basically. So, one of the big guys, he constructed a mall, okay, and then people were not coming. They said, okay, shut down the mall. They'll build another one. Okay, they shut down the mall. They'll make another one. Okay, does this seem practical for you? You constructed the mall, maybe 1 million BD, 2 million BD. Okay, now people are not coming there for one reason, some other reason. You try to solve the reason, right? You try to solve the problem instead of shutting down the mall, building another one, right? Okay, so this is what we mean by feasible. That guy came up with the idea. If you were given the chance, you will look for other options, right? But this is an option. It's not working, shut it down. It's an option, right? Okay, but it's not the feasible option. It's not a practical option. Clear? Okay. This happened real time. Okay? This is a real time example. This happened. We constructed the mall, nobody was coming. We shut it down. We will build something somewhere else. Okay, forget about it. I have too much money. Okay, so look if the idea is practical. Okay, look at the cost, look at the time. Practicality can also mean that you are looking to do something, okay, which may not be available within the resources you have. Okay, the resources which you have, which may not be practical. I will give you another very rare example. None of you were there, but anyway, we had the gas lecture last month, February. So that guy, when we were having a talk, he was telling me about they were doing excavation for pipelines. So it's a very deep excavation because it's for oil pipelines, very deep. Okay, so for deep excavation, they have to put supports on the side. So if people are working there and soil falls, then it's gone. Okay, people will die, obviously. It's like 2 meters, 3 meters. Something falls on you, then you are gone. Okay, so you have to put supports there. Okay, so the type of supports they were using were not steel, some soft material, maybe aluminum or something. Okay, or wood. Okay. No, cardboard. Sorry, cardboard. So cardboard works if you are doing a small excavation. It doesn't work for this thing, which is 2 meters, 3 meters, 4 meters, and this big. Okay, like it could be big as the half of the classroom. The excavation could be as big as the classroom itself, by the way. Okay, and it's very deep. And they were using cardboards. Okay, so he told me that I went there and I said, this is unsafe. I have to change it now. Okay, so what can we do? Okay, we will redesign. This is also designed, okay, by civil engineers. The support system is also designed by civil engineers. Okay, we will redesign. It's unsafe, we have to redesign. So they redesigned the whole thing, okay, and they were putting like, instead of one support, they were putting 100 supports, just to give you an idea, okay. So if they need one support, they were putting 100 supports. Why? Because they said we cannot change the cardboards. Our company only has cardboards. So we can add 100 supports instead of one, but we will not change the material. So, yeah, steel support is a lot easier and it requires less supports, but for them it was not feasible because they don't have it. Okay, it's a regular job, obviously. Pipelines are kilometers, okay, and there are multiple projects. So for all those projects, if they change the material, it may cost them like 1 million BTS to buy that much steel. The cardboard they already have. Okay, okay, it was fine. Redesign it. It may not look good. It may become more, expensive for the project, not for us, for the project. Okay, and there's a better solution. But right now, we don't have that material, so we cannot use it. Okay, just to give you an idea about what we mean by feasibility. Okay, so feasibility includes, is the idea practical? Is it a good, sensible decision to do it? Okay, and is it possible for the people who will do it? Okay, so in that example, it was not possible for them to build steel supports. It was not possible. So it was not feasible for them. Okay, even if it takes less time and less cost, they will not do it. Clear? Okay. Okay. Then on the basis of your brainstorming and planning, you come up and you evaluate your options. These are the options we have. For each option, this much cost, this much time, and these many resources. Okay. Then on the basis of that, you do your evaluation. Okay. Obviously, you can save time, or it may have more cost, right? I can do the same thing with 10 people in 1 week, and I can do that job with 5 people in 1 month. Okay, so the first option takes less time but more people. The second option takes less people but more time. Okay, so yeah, it's not that simple. The best solution may not be best from all aspects. Okay, the best solution may not be the best from every dimension. Okay, so you have to evaluate and then you will select the best option. Okay, and you have to select your on the basis of your priorities. Okay, so you have to ask the client, what is your priority? I can do this job in 1 week, but it will cost you 1000 BT more. Are you willing to pay it? He says yes. Then you go ahead with it. Okay, or you tell him I can. He says no, I cannot pay 1000 BT more. So you say, we tell him okay, now it will take 10 more extra days. Okay, fine. Okay, so there is some negotiation required here. Okay, and you need the decision from the client, obviously. You prepared your solutions, you analyze the resources, and you analyze everything. Now you think if this is the best option, you go to the client and he will tell you that is this option valid for him or her. Okay, on the basis of that, you will go on. And they are the compromise, as I already mentioned, they are the compromise. Okay, you may not go for the best quality material because the client is not willing to pay. Okay, or you may have to have more cost because the client wants to finish it fast. Okay, so in this stage, you need the decision from the client, and there is some compromise involved. Okay, the best one is not the best from all aspects, as I keep on saying it. Okay, once you select the best option, then you start preparing detailed plans for that option. You start making the design, you start preparing the drawings, you start hiring people who will implement that solution. Okay, you may need more contractors, you may need more labor, you may have to buy material, you may have to buy software and so on and so forth. Okay, and then you start documenting the design, you start preparing and documenting the design of your solution. So we start preparing the reports, the testing, initial testing, the drawing design. Okay, then the next stage is you build or implement your solution. Or it could also mean develop a detailed plan according to different fields, obviously. Okay, in our field, once we have the design ready, then we go for construction, right? So our job is this one. The plan is ready, the design is ready, you start going for construction. You go in the field and you start looking at the land and you start preparing it. Okay, start developing the structure. But for example, if you are in the IT field, then your product is what? The software or the app, right? So what do you give for the software of the app? You give the design. This is my final design. Now you run the software. Okay, so it depends upon what type of field you have. Okay, so you then build, create or implement the solution using the plans and drawings you have already followed, so you have already prepared. Okay, is this the end? Is this the end? Now work finished, right? Done? Huh? We don't know, right? Okay, but there are other steps as well. This is not the end, by the way. We have to still earn, right? Who will give us money? Okay? If the problems are solved that easily, then we will be jobless in a few years. Okay? We don't solve the problem like this. Okay? You have to drag it. Okay. Once you have implemented the solution, it is also part of your job to see what has happened actually now. What is the end result actually? Okay? So, crack in the wall, you did something, the crack is filled, okay, job done. Okay, but still you need to now take some feedback. Maybe the crack reappears after 1 month. Okay, so the solution you applied did not work. Or how would you know if you said Tata, bye, I'm going home, never call me again? Okay, so testing the performance of your solution is part of your job. Okay, testing the performance of your solution is part of your job. If your job was constructing a building, obviously a building is for 50 years. Now, even if you live for 50 years, who cares for a building, right? But when the construction is finished, they do the testing, they do the surveys. Is the building constructed according to what we already wanted? Okay, they prepare reports. Was there a delay? If there was a delay, what was the reason? And so on. Okay, so this also comes under testing the performance of your solution. Okay, these end surveys and preparing reports also comes under testing the performance of your solution. Okay, so testing does not only mean that you go in the lab and test it. Testing also means you monitor it. Okay, and you see, you check, and you compare it with the guidelines, you compare it with the standards and rules. Okay, was it the same or not? Clear? Okay, so testing and iteration means what? Iteration means what? Do iteration, right? In maths. Iteration means what? Repeat it, right? Just repeat it. Or repeat it with improvement or change. Okay. We repeat it with the term improvement or change. So we applied this solution. Okay. What will happen if I change this in the solution? Okay. I bought the material from this contractor or from this site, or the aggregates were from this soil or this type. What will happen if I change that type of aggregates? Okay. So this thing can be done because now you know the end result. So now you can see what changes you can make to improve it. Got my point? Okay. So this is, once you have built, everything is finished. Now you see, was it according to what we wanted? Okay. Maybe yes, maybe no. In both cases, how can we improve it? This is also part of, maybe everything is fine, but still there is chance for improvement, right? The iPhone, they launch every year a new model, right? Whether the old one is good or not. They are getting worse. Anyway, but they launch it, right? What is the idea? There is always room for improvement. Okay, so you test it and everything was fine, but still you can think about more iterations. What can be changed to make it even better? Okay, so this is done. You document everything. Okay, whatever you have, your findings, your solutions, your improvements. You document it. You prepare reports. You put the report in your office library. You give the report to the client. If the client is from the ministry, they have their own records and they keep the records. And this is from where you can get the old data. I mentioned, right, that something happened in the wall, you don't know what to do. You can go back to the old data and see what others have done in the past. This is for future you. Okay, or in future somebody else. Okay, so documentation. Then you communicate the entire thing to all the stakeholders. Okay, communication now is becoming more important as well. You communicate the results to all the stakeholders. Those stakeholders are client, your contractors, okay, your boss, your accountant, okay, maybe the government, the ministry. Maybe it's a private job, but the ministry is still involved, right? You have to get the approvals and everything. Okay, so they are part of the stakeholder group. Okay, so then whatever reports and whatever findings you have, you distribute it to all the people, and they should keep it in their record. And your team members who are working with you in your project are also part of the stakeholder group. So the job is finished. I was working with 10 people. Maybe they are junior than me, but still they are part of the team. So you tell them, this happened, this happened, this happened, we find this and this. So next time when you are working with the same team, they are more informed and they can work better. Okay. And the last thing, I mentioned it even in these slides as well, a very important part of our job is to do the maintenance work. Okay, the maintenance of the facilities is also part of our job, and I already mentioned there are engineers who are working in hospitals and banks, and basically they are doing this. Okay, so and obviously this happens after the work is finished, right? So this is now long term, or you can say it continues till infinity. Maintenance and optimization continues till infinity. Optimization means what? What do you mean by optimization? Optimization means what? This is the optimum point. Optimum means what? Highest point? Somewhat correct? Yes? Either highest. Yeah. Yes? Highest efficiency, very good. It can mean both. Okay. But optimum means the best possible. Yeah. It should give highest efficiency. should be the highest point or the best point, okay, in some aspect, but it means highest possible. Okay, highest possible. So we are mentioning it here because now you already have a building, right? You already have a building. Now let's say you are expecting in a class 50 students, but now I have a class which has 60, 70 students. Okay, so how do we manage it? Do we start, demolishing these walls and start making bigger rooms and so on? Okay, we can do this obviously. This is one of the solutions. Okay, but is it the optimum solution? Okay, so optimization means coming up with the best possible solution with whatever you already have. It's not a new project now. It's not a new project. The project is already there. Okay, the project is already built. You already have everything. This is what I have. I'm not building anything new. How can I make the best use of it according to my situation? This is called as optimization. Okay, maintenance you understand, right? Maintenance you understand, the cleaning and changing of things which are broken and so on and so forth. This is maintenance. Okay, optimization means you are trying to use the resources which you already have, the project or the space and the structure which you already have to the best you can. Okay, so it's not something new. Optimization means using the existing resources in the best possible way. I have only 4 classrooms. How can I use it in the best possible way? In Pakistan, we had a building. New department was constructed. It had 4 classrooms. For some reason, it had 4 classrooms and 1 computer lab. They did not think about the number of students will increase and we have to make more sections. They did not think about that. Okay. So what they did? Okay, we have 1 computer classroom, computer room, computer lab. Okay, which can hold 1 section as well. So now we will make it 5 classrooms. The computer lab is part of the classroom. But what do we do with the computer lab itself? For example, if you have an AutoCAD course, then you need people in the computer lab, right? So now we have to change the timetable, the schedule of the classes, that when this room is used for other classes, the computer lab, the AutoCAD is not in the same time. So they can go to the other room. Okay, this is called as what? Optimization. I still have the 5 rooms, but I'm using it for maybe 6 sections. Okay, by managing the timetable. Clear? Okay, so this comes under optimization. Okay. Any questions?